Hey 8th graders, today's lesson is called Phases of Matter, and your learning targets for today's lesson. I can differentiate between solids, liquids, and gases, and I can identify the properties of solids, liquids, and gases. So we're really going to talk a lot about what makes a solid, a liquid, and a gas, and we're going to use water a lot as our example. Okay, so your notes today, we are starting a new note sheet, so if you are absent, you will need to get this when you come back. Make sure you guys get your names on it. First thing you guys are going to add is your unit question. How can the appearance of a substance change without it becoming a different substance? To your vocab, you're going to need to add phase and freedom of movement and draw a picture of each. Phase is a noticeably different form or state of the same substance. So we're going to talk a lot about water with this unit and how it can exist as a solid, liquid, and a gas. And why with the molecules, why do they have those properties that we see for each of those three different phases, even though they're all made of water molecules and essentially are all pure water. Okay, freedom of movement is going to be one of those things that we talk about when we talk about molecules of a substance. This is going to be the way the molecules in a substance move around relative to each other. So do they kind of move away from each other? Do they stick close together and barely move next to each other? How does that look? Okay, and then key concepts 1, 2, and 3. A solid keeps its shapes because its molecules only move in place, not around each other. A liquid can flow because its molecules move around, not away from each other. And finally, a gas does not have a visible shape because gas molecules can move away from each other. I really like to ask the question too of why are gases invisible? Okay, so when we talk about this concept of molecules, freedom of movement, and gases, where the gas molecules move away from each other because we can't see molecules at all with our naked eye, because these molecules are spaced so far apart and moving away from each other. That's why gases are invisible. Versus a solid, all of those molecules are compacted close together, and that kind of gives us something quantifiable to our vision where we can actually see a solid but not a gas. For your bell ringer today, you need to read this article, Weird Water Events. We have a little snippet here, or a little picture and a caption from this article. You guys will use the information in that article to answer this question. Describe what you think the phrase greater freedom of movement means. Think of having more freedom. What does that mean for the molecules? Okay, so go ahead if you haven't already. Take a second, pause this video, and go read that article and answer that question, and then come on back. All right, so today's assignment is actually going to be mainly on a worksheet, but if you're absent working from home, you're more than welcome to kind of just jot down some notes on a piece of paper, or maybe you've already returned, you grabbed the worksheet, and you are watching this video on instructions how to do it. Okay, so today you will be using a combination of videos, notes, and the sim to learn more about solids, liquids, and gases. To receive credit for this assignment, you will complete the worksheet that is handed to you in class. We will correct that worksheet together and then staple it onto our notes page to help you throughout this unit. If you are absent, you will need to get this worksheet from me before you can complete this assignment. The worksheet will look like the image on the next slide. So again, if you guys are watching this for the first time at home, you haven't gotten the worksheet yet, you're more than welcome to kind of jot some of this down on a piece of notebook paper. And then when you get back, you guys can grab the actual worksheet and then just add in your answers. Okay, so your worksheet will look like this. We're going to kind of do this first part together, which is the solids. So we've got 4 parts that we're going to do for each of these. There's going to be 2 spots where you do a drawing for solids, liquids, and gases. And then there's also going to be 2 spots where you guys fill out some properties, like how the molecules behave, what the kinetic energy looks like, what the molecular attraction looks like, what just in general that phase, what kind of properties that phase has. So this is the top part here is going to be your solids, and then right here we're going to have those same boxes for liquids, and then right here we're going to have these same boxes for gas, and then here in a second we'll talk about what we're going to do with the middle. So I'm going to go ahead, I'm going to come back to this in a second, but the things I want to show you first are the instructions and then the materials you guys will be using. Okay, so fill in the blanks on all 6 boxes describing solids, liquids, and gases. On the next slide we're going to see a word bank. The sim is going to be on slide 9, which we're going to use a lot to help us kind of figure out some of the properties of these solids, liquids, and gases on the molecular scale. And then there's also a video on slide 10 that will help you guys. So I want you to use a combination of all of these things to help you answer these questions. And then finally, there's also going to be 2 drawings that you do for each solid, liquids, and gases. One's going to be a macro scale drawing, so that's something that we could see with the naked eye, versus a molecular scale drawing would be what the molecules of that object look like. The square you're going to be drawing drawing those in are going to be a container for the solids, liquids, and gases. Okay, so we'll come back to that here in a second. Slide 8, we've got a word bank. These right here are appearances. And you might see some things where we use them twice. For instance, stays at the bottom of the container. We would use that for both liquids and solids, but not for gases. So with this first column here, you guys might see some use of these words more than once. Okay, versus these three little classifications right here: freedom of movement, average kinetic energy of molecules, and attraction of molecules. Notice that there's 3 options for each of those, so we're going to designate one each to solids, liquids, and gases. So once you use one of these and these on this side here, you won't use them again. Slide 9, you have the link to the sim, which I'll open up and show you right now. Okay, so this is going to give us an opportunity to explore what solids, liquids, and gases are going to look like as far as the molecules in those solids, liquids, and gases. Okay, and then finally on the next slide, you guys will have a little video that goes through the states of matter. So this is a really helpful video as well. In fact, it might be best to start with that. Okay, so what we see right here is when we press play, okay, we have different substances we're looking at over here, so we can kind of mess with those substances. We can see their molecular attraction. We want gravity turned on so we can see if they stay at the bottom of the container or if they refuse to do that. And we can see like, okay, this for the most part, all these molecules are on the bottom. I can click on a molecule and kind of watch it move and watch its little pathway. So this molecule is kind of moving around the other ones. And for the most part, most of these atoms and molecules are staying at the bottom of the container. So this would actually be a liquid. Okay, if we look at this one here, we've got one molecule is kind of staying in place, moving next to the other ones. We can see it's kind of maintaining some kind of shape. Remember, when we look at a solid, we're not going to see the molecules of that. So we're not going to see this kind of bouncing edge to an object, right? We would zoom out and we would see that this would be something that would maintain its shape. Okay, it's staying at the bottom of the container. That little molecule isn't slipping past any other molecules. It's kind of staying wedged in between all of its neighbor molecules. Okay, so that would be a solid. And then finally I can click on something like this and see, all right, these are going to fill this whole container. They're going to move away from each other. I can click and see how these molecules really don't want to be next to each other, okay, and how they're using this whole container. Okay, so what we're going to do is I'm going to do this example with you guys, and I'm going to kind of zoom in here so you can see we're going to do solids together. So with kinetic energy, okay, I always kind of like to think of this as far as an ice cube or water. Okay, with kinetic energy, when we have water in the solid form, typically it's cold, and we've taken some of the energy out of it. So when we talk about kinetic energy in this word bank, okay, we're looking at having low kinetic energy. So we're going to start here by saying my kinetic energy is low. Okay, blank and holds its shape, and it's blank, or excuse me, it's rigid. So we're going to put rigid in here. This is again is off of our word bank. So rigid meaning it has kind of a set shape, it holds its shape. And then this one is going to be stays at the blank of the container. So if we look at this, it's going to, if we look at the last one here, stay at the bottom of the container. So I would fill that in with the word bottom. Okay, so stays at the bottom of the container. I know that's kind of hard for you guys to see, and I'm kind of slopping it into these little spaces. So that's the first one I would do over here. As far as my attraction goes, this is how much the molecules like each other. So if I go to the sim and take a look back at my solid I had, which I believe was A, okay, we can see all these molecules are staying at the bottom of the container. And then as far as attraction goes, we can look right here and see attraction level and say, all right, this is high, meaning this little molecule right here really likes its neighbors. Okay, if it didn't, it wouldn't be so close to them. So as far as attraction goes, I'm going to say it has a very high attraction. And once I use that one, I'm not going to use high attraction again. Same with kinetic energy over here. Low is going to be designated solely for our solids, not for our gases or our liquids. Okay, and then as far as my oh, sorry, I'm not done yet. Molecules are blank together and only blank in place. So I'm going to say they only move in place, not around each other. Okay, so the molecules are close together. You guys will notice that there's spaces for each letter. Some molecules are close together and only move in place, not around each other. So if we look at this, that's pretty accurate to describing our solid. Okay, the last two things we're going to do here are going to be a macro scale drawing. So if we were to see, again, if we talk about water, Okay, a macro scale means something we can see with the naked eye. So when we think of water in its solid form, I think the first thing I think of is an ice cube. So we're going to assume that this little box right here is the container in which we hold our ice cube. So our ice cube would rest on the bottom, gravity and such. Okay, and it would have a pretty distinct shape, right? We all know what an ice cube looks like. So I might draw something like this and say, all right, this is ice. Okay. Versus my molecular scale drawing is if we were to zoom in on this, what would the molecules of this ice cube look like? So because we know that they stay at the bottom of the container, we're going to draw our molecules down here. Okay. And then they're all really close together. And we're going to have some kind of distinct shape. It's not taking the shape of its container, it's staying at the bottom, and it's going to kind of maintain its shape right here. So we're going to draw the same number of molecules no matter what, just because we might have different kinetic energies or the molecules might be looking different. If we're talking about water in 3 different phases, solid, liquids, and gases, these molecules would all be the same in all of them. So maybe that's kind of what you guys focus on as far as your guys' molecular scale drawing. So I just completed water for you guys. So you guys will do your liquids on your own. So liquid is right here, right here. We got the attraction, the kinetic energy, and then our 2 drawings. Gases are over here. We got attraction, kinetic energy. These 2 boxes describe the molecules, and then our macro scale and our molecular scale drawing. So you guys will complete those parts. For the next part of this, you're going to label the other 5 phase changes. These are going to be the arrows in the middle, and you're going to use video on slide 12 to help you. You guys can also use your exit ticket on slide 14 as kind of a word bank. Let me zoom out just a little bit more. Okay, where we have melting, evaporation, condensation, freezing, and sublimation. So you're going to learn about those from the video on slide 12. Okay, and then in the middle of your little worksheet, again, you've got these arrows. One of these arrows is already labeled for you. So deposition is moving from a gas to a solid. So you guys are going to identify moving from a solid back to a gas, solid to a liquid, liquid to a solid, liquid to a gas, and gas to a liquid. Again, if you kind of need a word bank, you guys can go cheat sheet on your exit ticket. Okay, once you guys' little worksheets figured out and you guys have finished your gases, your liquids, and then filled in the information I gave you from the solids, plus labeling those phase change arrows, you guys will go ahead and complete your exit ticket. In the 3 boxes below, draw 10 molecules in each that reflect the molecules in solids, liquids, and gases. This box here will act as a container. So again, draw 10 molecules in each. Show me how those molecules behave in a gas, a solid, and a liquid. This is very similar to your molecular scale drawing. Finally, the second part of your exit ticket is labeling these arrows. You guys can click and drag the different labels to the correct arrow. So this is solid to gas, gas to liquid, liquid to gas, liquid to solid, solid to liquid, and then just click and drag and pull those up next to the correct arrow. Okay, once you guys are done, go ahead, hand this in, and the main thing though is that you have your worksheet. That's going to be part of your guys' notes. So make sure that is complete, corrected, and then once it's corrected, we can get it stapled onto the back side of our notes next to our vocab. Hope you guys are having a great day, and I'll talk to you soon.